Hey, welcome to my YouTube videos on Kaggle Titanic. What I want to do in this series is I want to take an easy dataset that I will use from Kaggle now and discuss a few ways and how can you approach a machine learning problem. How should you go about building your classifier? What is a good classifier? What is the difference between several of those classifiers? And maybe what are some of the advantages and disadvantages. And I think I will learn something myself. At least I plan to go very in-depth on every classifier, so there will be something new for me. In this easy introduction, we will look a little bit at the data set, maybe make our first classifier, submit a prediction so that you can see how that works, and then we will go deeper and deeper from there. So, Kaggle Titanic, what is it? I read somewhere on Reddit that new people to machine learning get pointed to this data set a lot because it seems to be fairly straightforward. And I briefly read the description. So it is a data set about the Titanic, and it is about which people survived the disaster and which didn't. So if you want to know more, you can go to the page of Kaggle and read about it. One thing you can see is we will get a data set that contains stuff like survival, which is what we want to predict. It's a Boolean variable, 0, 1. It has the P class, which is the ticket class, so first, second, and third class tickets. It has the sex of the person, the age, the number of siblings and spouses that are on board, the number of parents per children, siblings per spouses, and parents per children. Naja. And we have the ticket number, we have the passenger fare, we have the cabin number, and where they embarked from. Yeah. So this is already a super old competition, and there's nothing to win. It's just for learning. And if you check the leaderboard, you will see there's a couple of people who managed to have perfect predictions even with just one submission. I kind of assume there was some prior knowledge to that, and that he or she might even have overfitted the data quite a bit. I mean, in a real world example, you would probably almost never see a performance like that. I am actually not quite sure which metric is used here. I couldn't find anything about that. Is it classification error? Is it log loss? No idea. Let's just dive in. So what we're going to do is I downloaded the data. If you click on the Kaggle page, click on the download all button, which is down here somewhere. Yeah, download all. You will get a folder which is called all. It contains the files. So train is the file that has the labels. Test is what we should submit, and gender submission seems to be the baseline model. So we can see the format of that file and see how we need to structure our prediction. So what we first do is we're going to import pandas, and we're going to read the file, the train file. Yep. So if you see here our data frame, maybe like this. So this is what it looks like. You can see there's a passenger ID. This is probably nothing we should use, but I will not make it the index of the data frame for a reason that you're going to see later. We have the label, we have the passenger class, we have the name, sex, age, everything I just read to you. So one thing when I start out with a data set, I usually like to do is I'm gonna get an idea of what is the distribution of the classes. So one easy way to do is you can just group by the label. and since we don't need all of the columns, passenger ID. So here we can see 549 died and 342 survived. But this view is a little bit limited and I don't like it as much. So what I usually do is I use the pivot table function. And in the pivot table function, you can specify values, columns, indexes. What that means is, in this case, let's just immediately look at the first variable. So we say the columns, the index of our new table should be the passenger class. And the columns will be our label, which is survived. And the values is going to be passenger ID. So if I would have made the passenger ID the index of the original data frame, I wouldn't have a good column to use here. So usually I leave columns like this. And as aggregation, we say we want to count. So now you can see this and you might say, that doesn't look a lot better. So usually I wrap this in a function where I can then pass my data frame. Here I would say did survived, and here I would say now we have proper labels on it, and then I want the margins. True. Yeah. So with margins, yeah. So what margins does is it adds the sum of all the columns and all the rows. And then the next thing I do here is let's do the survival rate of that particular feature. Would be the number of people that survived divided by the total. So now you can see we can get a bit better look of the data set. So immediately we took one of the columns. We could have probably done it slightly differently by just aggregating one row, but we have everything we need here. We see passenger class 1, 2, and 3, and then all combined. And how many are dead, how many survived, what's the total in this group. This is more or less just for calculation. And then what's the survival rate. Immediately we can see 62% of the people in class 1 survived, while only 24% of people in class 3 survived. Overall, if you take the average over the whole data set, 38% survived. So this is good to know. Now we get an idea. Let's probably wrap this in a function because we're going to use it later. Feature, and the feature was P class. And then we immediately pivot the feature again to see if it worked, and I forgot the semicolon. Okay. And yeah. So this immediately worked. Easy, nice. The next thing we can do now is, without much thinking, we could actually, if we wanted to, build an easy model which uses all the numeric classes. So we can use passenger class, age, sibling, spouse, count, parch, fare, and that's it. We don't need to do any pre-processing on that, and we can see how good we get. Let's try this, and let's just assume we don't know anything and we just say, oh yeah, nice, let's do it. And let's use logistic regression. From logistic regression. One other thing we need to do is we need to do cross-validation. So how that works is you have a data set, you want to train on it, and you want to figure out how good would your classifier be in real life where you do not yet have the label. In terms of Titanic, this might be a bit boring because after the ship sank and people came back, you kind of had the label from everyone. You know if the person survived or not. But you could imagine that this is some click-through prediction or something. So you have a data set where you have certain features, and then you try to predict whether a user will click or not. And then from your training data set, you want to kind of make sure you're not overfitting your data, your classifier is working correctly. So what you usually do is you split it into several parts. There's several ways of doing this. Cross-validation is one way where you usually split your data set into multiple sets. You train on one set and you predict on the other. There's different types of that. There's called k-fold or n-fold cross-validation, where you say I split my data set into n parts, and then you train on n-1 parts and you predict the last one. We can do this with what do we have here? Cross-validation. They have the cross-validation package. And you see there's a whole kind of cross-validation stuff like k-fold, label k-fold, leave one out, where you always just remove one sample, train on the rest, and predict that one sample. What I'm looking for and always use is the stratified shuffle split. What does this do? It randomly selects training and test data in a way that the proportions of the good versus bad stays the same in both sets. So this is especially important if you have very unbalanced classes, because say everyone except one person or everyone except 10 people survived. If you were to randomly draw two data sets, it's highly likely that in one of them no one actually survived. So let's make a splitter. Wait, let's immediately run this. Okay, the first thing you see, the splitter needs the labels as a parameter. So we give him the survived column, and then we say, okay, 10 iterations, test size 10%, random state. Let's fix this. Okay, we have a splitter, and then just for now, so we ran through the for loop. We break after the first iteration because I just want the first index. And what this returns is the index of the samples that I should use for my training data. So now I can do data frame ix. Nope. Okay, and I always use this, and it tells me that ix is deprecated, and I should use for positional index. I think ilog is the right one. Okay. So just to show you again, this one starts with index 601, 771, and so forth, and so on and so forth. And if I select this now, I get exactly those rows from my data frame. This will now be my training data, and the other one I will use for testing and evaluating how good am I actually performing. So if we wanted to do this, we can do xtrain is this one, and x. shortest index. So now we have this. Now we need to do two more things. So currently xtrain, or let's leave it like this, is fine. Ytrain and okay, now we have both labels and data. So then what I usually do is I define the columns that I want to use for predicting stuff. I define them separately and then later on I use them. So we said we want to use P class. The passenger class, we already saw this is a predicting. We can use, no, we cannot use that yet, age. Let's just use all the numeric columns as they are. This is very suboptimal, but we will improve from there later. First I want to set up the baseline and the fare. Okay, and now we have df. So you can see if I select those columns, it's only them, they're numeric. Some columns are none. We need to make a decision here on what we want to fill into those none values, otherwise we cannot train a classifier. One thing that I do with logistic regression, and it's fairly safe to do, is to fill with 0. What happens then is that for this particular feature, the person will have 0 instead of any like mean value or whatnot, and the odds of dying will then be modeled in the intercept of the model. All of this we're going to come to a little bit later again. Let's just try this out. Logistic regression. Ytrain. And here we, I just said we should fill it. Okay. So we did this. Now we need to predict the probability, just so you can see. X tests, columns, and then that's it. Yeah. Later on we might fill something different. So here you can see the output is an array with a list of 2 items, and the first is the probability of dying and the second is the probability of surviving. One thing that we actually need to figure out is, are we predicting death or that assumes all females survive. This is the submission. Just 1 second. I'm trying to find out if we... so, yeah, sorry. Okay, I got confused. Survival. The first class, this class is death, and this one is survival. Yeah, now I'm getting a bit confused. Anyway, so what we do here is we only want the first column in this array. So what you see this does is, so here we get the probability of dying and the probability of surviving. And what this does is it says I want all fields of the first column, which now would give me the array with 29, 22, 18. So here you can see 29, 22, 18. Oops. 18. So, and these predictions we can use and then feed them into metrics. So, one thing I said earlier, I haven't quite found out which metrics we're gonna be judged in this competition. But I'm just gonna look at some of the ones that I usually think are interesting. And I'm going to explain later why they're interesting. Maybe not so much in this particular competition, but for now, let's just see what we do here. So y test and prints. And yeah, y. Okay, that's not super good. Okay, so our ROC area under the curve is 67. So we're better than random. If we were random, this would be 0.5 and higher is better. We're going to look at this plot later on too, so we're going to see more about this. Log loss is basically entropy loss between the classes. So if you, how to explain it, instead of just saying, oh, you misclassified this example, it also counts by how much did you misclassify this example. So it's worse to say this person died for sure than just to say, oh, I'm not sure. So the probability of dying is 0.5 in case that the person actually survived. So because 0.5 is closer to the actual class. And then average precision score gives you the area under the curve in the precision recall curve. This kind of gives you a hint on how precise can you be with recall. We're also gonna look at this later. This may be esoteric to some other metrics that you've heard about in courses or classes. So let's look at some more common classes. So we can do precision, we can do recall, we can do F1, we can do accuracy, okay. Oops. Classification, binary and continuous. Which ones are binary? These ones? For this I actually need to give a prediction. So I'm going to explain this in a second. Session recall. Precision score. Oh. What did I do? Recall. Recall score. Okay, I messed it up. This belongs here. And this belongs here. Wow. Something like this. Okay, this works now. So accuracy says out of the wait, no, I'm blocking a bit. If we say someone survived, well, I'm having a hanger here. Let's start with recall and go from the back. I'm having a hanger. So recall actually says, out of all the people who survived, how many did we actually say that they survived? Precision says, out of the people that we said that they survived, how many actually survived? So recall tells us how many of the total survivors did we actually classify as survived. And precision says, out of our prediction of people who survived, how many actually survived. This is important because we want a high recall, because if somebody survives, we want to also say he survives. And we want to find all of them. And precision is important because if we would just say everyone survived, then we would have a really good recall, but we would also misclassify all the other examples. And accuracy just says out of the, so what does accuracy say? Oh god, let's look it up. I'm in stupid state right now, but it's late here. It's 11:30. Yeah. It's just how often are we right. So if we say survived and he survived, it's good. If we say died and he died, it's good, and everything else is an error or a mistake. So 70% of the time we got the correct class. You can see though, 70% of the time, if we say someone survived, the person actually survived, and only 40% of all survivors were classified correctly. So we have quite some room up. One thing we can do now to wrap up the episode is what this easy classifier give us. So if we now check how does the submission has to look like, so we just have to give one row, which is the number of the row, and then a prediction. So it's so this one is the test data frame. Don't get confused with the word test now. Test in this case means this data frame does not contain a label. We just need to predict it. So what we do here is we basically do the same pre-processing that we have on our other data frame. And we predict that. And then we actually do we have does this column have to have a header? Unsure. Let's so here you can see now we added the prediction column, which is what we predict. And we now want to write passenger ID and prediction. So 2 CSV and then is this not called headers? Passenger ID? And it's not headers. Header false, everything false. Let's check this out real quick. So yeah, this now just has columns and labels. Okay, if we here I want to copy it here, because when I click on submit predictions, it will actually go to documents. Let's choose this and upload it. And then let's see where we end up with a really stupid classifier. We didn't do anything. Upload is complete. No. Let's make this submission. It's good that we are next in line. Let's name this. So in the next episodes, we will actually take a closer look at the variables. We will do some more pre-processing. And I think we will stay with the logistic regression for quite some time now. We're going to do some fine-tuning. We're going to look at the variables and whether we need to do some pre-processing and what we would look for and why we would look for that. And then we will move on to maybe tree-based models, and I assume this is the ones that work best. And we look at all the hyperparameters of the model and how we want to tune them. Column 892 was not expected. Oh, so we need to change the format slightly, and I still want to do that so that you can see it. We need to store this in arrived, and it actually should have a header. Yeah. Okay, and we do this again. And then second prediction. Oh, yeah. This is also something something about Kaggle that in the past when I did a couple of competitions, you always have to upload like 2 or 3 times until you get the format right. Almost done. I'm looking forward. Yo. We are place 9,471 out of 9,938. So you can see there's a lot of room and potential for improvement. And you can see there seem to be a couple of other people who probably built exactly the same classifier. Or maybe this is even the as good as the what's it called, baseline model. Anyway, more on this in the next episodes. I hope this was interesting to you, and thanks for watching.